Good morning. Happy Sabbath, and thanks for having me back. It's been a couple of years, I think, since I've been here. Mostly because my son Wesley was diagnosed with Crohn's disease a couple of years ago, but we've done a few interesting things where he's been in remission for 2 years on diet alone, no medications at all. So anyway, it's been pretty interesting experience for me, and kind of miraculous. So that's, now that he's all better, I'm back. So, my current topic for today is something from nothing. I was thinking about this, studying some arguments from some modern physicists, Hawking and Krauss, who are arguing that the universe popped out of nothingness and made itself. And so it started reminding me of Darwinism in a way, so that information kind of just popped out of nothing and made itself more and more complex over time, and how things evolved from nothing. And it seems to be this a similar thread of argument throughout all naturalistic sciences, from biology to physics. So it's like, well, let's kind of look at that and see what the arguments are on both sides and which one makes more sense, at least from my perspective, and you can make up your own minds. So let's get into it. So the basic idea is, what is fundamentally real? Oh yeah, can you see if you could make at least these front ones down a little bit? The basic idea is, what is fundamentally real? And it turns out that what most of us think of as real things are not really real. They don't have their own independent existence, not even time. Time actually is dependent on something else for its existence. And so it starts to kind of sound rather biblical as you look at it a little bit, because in Genesis 1 it starts out, in the beginning God, and then God from there on just speaks things into existence. He just, by the Word, everything is based on the Word according to the Bible. And so that means, according to the Bible, that the most fundamental thing in the universe is the Word, or information. And here's a few passages. Jesus answered the devil who was trying to tempt him to turn stones into bread. He says, "It is written, man shall not live on bread alone, but by every word that comes from the mouth of God." Same thing for the centurion. The centurion is one of the first people on the planet to actually catch on to who Christ really was. And he says, "You don't really need to come to my house to heal my servant. All you have to do is say the word." And this was shocking to Jesus, that someone actually figured him out. He says, "Wow, I've not seen this in all of Israel. This guy is amazing." And of course, later on, the disciples finally caught on. It took them a little longer than the centurion. But John, the Epistle of John especially, is the most metaphysical gospel there is. And he says, "In the beginning was the Word," talking about Christ. And it's interesting that he kind of paralleled the passage in Genesis, "In the beginning God created the heavens and earth." And he kind of enhanced it a little bit. He says, "In the beginning was the Word." And then the Word created everything. Nothing was made without the Word. And so it almost seems a little bit strange, in a way, how the Bible describes God or Christ as the Word. And Paul then starts talking about it, and he says, "He is before all things, and in him all things hold together." It's almost like a mental projection of the way Paul describes the nature of God. He says, sustaining all things by the power of his word. Again, everything is based on this word of God. So what are scientists saying about all this? Because it used to be that everybody thought this was all just nice poetic language. But it's no longer poetry anymore. It's actually turning into science. Started with Einstein, because Einstein is the first one who basically said, hey, mass does not have independent existence. Mass is actually fundamentally energy. And energy cannot be created or destroyed, only change from one form to another, according to the conservation law. And energy itself, Einstein didn't realize this himself, but later on it was discovered that energy itself has a more fundamental basis. It's based on information. And like energy, the total information of a system cannot be created or destroyed, only change from one type to another. In other words, the underlying computer-like matrix, and you can think of it as the surface of the pond if you like, the pond itself cannot be created or destroyed. It always is, and you can change the shape of the pond, but the pond itself, the fundamental properties of the pond, cannot be changed or destroyed. So it's kind of starting to sound rather biblical. Professor Leonard Susskind, he wrote In short, the world is like a ghostly three-dimensional illusion cast by a hologram. So it's based all on information as a most fundamental aspect of the universe. So you're like, well, that's really bizarre. How can everything be based on information according to physics? Well, it turns out that everything is pixelated in the universe, and the most fundamental property of the universe is information in it. It's almost like it's computerized, like a bunch of zeros and ones. And then what we experience is just kind of a projection of this computerized universe. But this has implications. If we have audio for this, this is a short video clip on the implications of this pixelated universe.
Inescapable. The universe behaves as a virtual reality. In light of the evidence, this is why this question is now taken seriously by experts. Which brings us to the next question.
The more interesting aspect to that question is, who's the programmer and where's the computer?
If the universe is a simulation, who is the simulator?
So it implies then, if you have the fundamental properties of the universe being information, where did that information come from? And for most physicists, it starts to force them, even sometimes against their will, to conclude that probably there's a creator, an intelligent creator. But not everybody's happy about this conclusion, and so people try to look for other options. And so it ends up being this concept, what I like to call turtles all the way up or turtles all the way down. And this is written initially by Stephen Hawking, who was quoting somebody else's lecture, where the scientist was lecturing in this about the origin of the universe in this hall. And it happened that an American Indian lady was in the back, and she stood up and said, "You're completely wrong about this origin of the universe. Everybody knows the universe was built, or the Earth at least, was built on the back of a turtle." And so he says, "Well, fine, I'll play along." He says, "What's the turtle standing on?" And she says, "Oh, you young whippersnappers, you don't know anything. It's turtles all the way down," right? And so he wrote that in his book. Oh, he liked that, turtles all the way down. But I'm asking you, now if it's, whoops, I touched the wrong thing. You can't see it now, can you? At least you get to see my beautiful family. All right. So if it's turtles all the way down or turtles all the way up, no one can understand where the first turtle came from. No one can understand how the Big Bang came from nothing, really, even though we're going to get into that a little bit. And no one can understand God or where God came from. But I think what we can know is which way the turtles are going. Are they going up or are they going down? And so we'll talk about that a little bit more as we go along. The first one to propose that it's turtles all the way down, that the universe came from nothing, is Alexander Vilenkin. And he wrote in this book, Creation of the Universe from Nothing, that our universe might have been formed by a quantum fluctuation. It's all based on quantum theory, and randomly in the background sea of the quantum bubbling of the pond, you get random universes just popping into and out of existence. Stephen Hawking took that idea and ran with it in his book Grand Design in 2010. He writes, because there is a law such as gravity, the universe can and will create itself from nothing. Creation, or spontaneous creation, is the reason why there is something rather than nothing, why the universe exists, why we exist. It is not necessary to invoke God to light the blue torch paper and set the universe going. And so where did he get this idea from? He got it from something called M theory. And what does the M theory, what does M stand for? It basically is a merger of 5 previously established string theories on quantum mechanics. And so the M basically stands for all kinds of things, whatever you want it to stand for. Matrix, master, mother, monster, mystery, or magic. And I like the one magic best because it doesn't really explain much of anything. But according to M theory, this is what Hawking wrote. So according to M theory, ours is not the only universe. Instead, M theory predicts a great many universes that were created out of nothing. Their creation does not require some intervention of some supernatural being or God. Rather, these multiple universes arose naturally from physical law. So, beyond the idea of something coming from nothing, he starts with the concept of gravity. Because gravity exists, right? Basically because the pond exists, then universes will pop in and out of existence. So is Hawking really starting with nothing? First of all, if you have your computer already there, you're not starting with nothing. You're starting with a lot. So anyway, it certainly impressed Richard Dawkins a lot, of course, because Dawkins is an atheist, and he's eager to find anything that kicks God out of the picture. So Dawkins wrote this about Hawking's book. He said, Darwinism kicks God out of biology, but physics remain more uncertain. Hawking is now administering the coup de grace, kicking God out of physics as well. So problems, though. There's a few problems with this because not all physicists are happy with Hawking's conclusion. In fact, probably the majority of physicists are not happy with it. Sir Roger Penrose being one of them. He wrote, unlike quantum mechanics, M theory enjoys no observational support whatsoever. In other words, it's a philosophical position, not a scientific or empirically rational position. It's based on the beauty or elegance of the underlying math itself, but actually has no empirical observation that you can make to support M theory. So without observational support, without testability, you really don't have a science, certainly not a Popperian type science. But some other physicists think it's a great idea. Here's Lawrence Krauss. He wrote another book in 2012 called A Universe from Nothing. He also starts with something. He starts with the quantum computer, but he said, well, if I had called it a wonderful universe, no one would have read my book. So he called it A Universe from Nothing so someone would read it. And but he got some harsh reviews, especially by one of the harshest reviews was by David Albert. He's a philosopher of physics, Columbia University, with a PhD in theoretical physics. And he basically said, Krauss' attempt to kick God out of the picture, here's how he described it. His pale, small, silly, nerdy accusations that religion is, I don't know, dumb. And he goes on to say, basically, where did the pawn come from when Krauss doesn't explain that? So he wrote, relativistic quantum fields. They have nothing whatsoever to say on the subject of where those fields came from, or why the world should have consisted of the particular kinds of fields it does, or why it should have consisted of fields at all, or why there should have been a world in the first place, period. Case closed, end of story. In other words, he's saying none of these guys explain where the quantum field came from, or any of these quantum states came from that underlying the whole universe. He said relativistic quantum fields, theoretical vacuum states, no less than giraffes or refrigerators or solar systems, are particular arrangements of elementary physical stuff. The fact that some arrangements of fields happen to correspond to the existence of particles and some don't is not a whit more mysterious than the fact that some possible arrangements of my fingers happen to correspond to the existence of a fist and some don't. You can arrange your fingers in a fist. That makes a fist. That doesn't, right? So it's no more mysterious than that. Different arrangements make different things. And the fact that particles can pop in and out of existence over time as those fields rearrange themselves is not a whit more mysterious than the fact that a fist can pop in and out of existence over time as my fingers rearrange themselves. And none of these poppings, if you look at them aright, amount to anything even remotely in the neighborhood of creating something from nothing. So they really haven't kicked God out of the picture at all, according to probably the majority of physicists, I would say. However, Richard Dawkins is still on the bandwagon. In 2012, he wrote the afterword to Krauss's book, and he said in part, even the last remaining trump card of the theologian, why is there something rather than nothing, shrivels up before your eyes as you read this pages in Krauss's book. If on the origins of species was the biology's death blow to supernaturalism, we may come to see a universe from nothing as an equivalent from cosmology. So he's comparing it to on origin of species, which not even Krauss appreciated. But anyway, can we have audio on this? This is a commentary on how the universe, you can get a free lunch universe, from Michael Kiku, American theoretical physicist, futurist, popularizer of science, very well known, and I think a very interesting guy. But here's what he has to say on it.
And so the universe could essentially be nothingness, which was unstable, and created a soap bubble. Now, you may say to yourself, well, that can't be right, because that violates the conservation of matter and energy. How can you create a universe from nothing? Well, if you calculate the total matter of the universe, it is positive. If you calculate the total energy of the universe, it is negative because of gravity. Gravity has negative energy. When you add the two together, what do you get? 0. So it takes no energy to create a universe. Universes are for free. A universe is a free lunch. And then you may say to yourself, well, that can't be right, because positive and negative charges don't cancel out. Therefore, how can the universe be made out of nothing? Well, if you calculate the total amount of positive charge in the universe and calculate the total amount of negative charge in the universe, and you add it up, what do you get? 0. The universe has 0 charge. Well, what about spin? Galaxies spin, right? But they spin in all directions. If you add up all the spins of the galaxies, what do you get? 0. So in other words, the universe has 0 spin, 0 charge, and 0 matter energy content. In other words, the universe is for free.
So it's hard to disagree with someone like Michael Keiko. I mean, here you got a universe for free, no energy, no spin, at least at 0 amount. And so how in the world can you argue that God is necessary? Well, it boils down to something based on information theory or even thermodynamics. What is the origin of thermodynamic order in the universe and the fundamental and functional information as well? He doesn't talk about the information content of the universe. Yet original information is required, both on the thermodynamic side of things and also on the informational quality of the systems, the functional systems within the universe as well. So where did it come from? Well, a quick review of thermodynamics. If you have 2 boxes, one side you have all the particles moving around, the atoms moving around, and it goes through a little slit, you have thermodynamic potential to do useful work because it creates a flow from an area of greater or lower entropy to higher entropy. And then if you put a little fan in the middle, the fan can spin and take advantage of that flow potential and create useful work. But once you have an equal number of atoms on both sides of the boxes all bouncing around randomly, you can no longer generate useful work because the fan itself will not spin in a consistent direction. And the other problem is, let's say you do have potential to useful work, you have the flow of energy, but your fan is broken. You don't have any blades on it. Well, it's not going to spin. So you have to have informational quality to make the fan blades as well as the original low entropic state of your system in order to create useful work. You have to have both elements, informational quality of the fan, where the fan blades are properly arranged, as well as the proper thermodynamic potential of the system, both. If you don't have both, you're not going to get useful work. And it turns out that once everything is equilibrated and you go back to basically 0 informational quality and maximum entropy, you cannot generate useful work. There's been several attempts to get around this. One of the most famous is the Brownian ratchet problem by Feynman, where you have a little ratchet thing that blocks the system from going in the opposite direction. It can only rotate in one direction. And on an atomic scale, you would think this would work and to take advantage of a random gas in order to create useful work. But the problem is that once the gas is equilibrated and it's not a heat sink, that little bouncing arm there, it bounces all by itself because of the heat of the system, and it makes the thing go both directions. So you really can't get around this idea that when your system reaches maximum entropy, you can no longer do useful work. And it's the most solid scientific law there is. Nothing is considered more solid than this idea that you can't get around the second law of thermodynamics. There's just no way. Once you get maximum entropy of the system, you're no longer able to get useful work out of it. It's very similar, in my mind, though, to a type of Darwinian mechanism, because natural selection is supposed to prevent random mutations from going downhill. Natural selection is supposed to make random mutations go uphill. But I'm going to tell you, it's the same problem on both sides of the equation. The same problems that happen with trying to get something for nothing for the thermodynamic system are the same problems of getting something for nothing in a informational system like biology. And this has been a well-known problem for a long time. Here's sketches by Leonardo da Vinci, who also tried to make perpetual motion machines. And finally he gave up, and this is his conclusion. He said, "O you seekers after perpetual motion, how many vain chimeras have you pursued? Go and take your place with the alchemists." Right? He said, you're not going to win, right? You're always going to fail. Same thing happened in biology with Louis Pasteur, you would think, because in the mid-1800s he did these famous experiments where he showed that life does not come from non-life. You have to start with life in order to get more life, at the minimum. And it gets even worse than that because eventually life decays over time because of random mutations take things downhill. But we don't have time to get into all that. The problem with the universe perspective is that the free lunch universe that we just saw Michael Kiku talk about isn't really a free lunch, because the universe, the Big Bang, didn't start with a maximum entropy. It started with extremely low entropy, finely tuned entropy that's almost unimaginably fine-tuned. Where did it get this very low entropy? The degree of precision of the Big Bang would have to be calculated by Penrose and several others, would have to be fine-tuned to 1 part in 10 to the 10 to the 123. In other words, 1 with zeros with 10 to the 123, 10 to the exponent 123, zeros following it. In other words, if you wrote zeros on every atom in the universe, there's 10 to the 80th atoms or so in the universe, you wouldn't have enough atoms by a long shot to write down this number. There wouldn't, you would write zeros, like even millions of zeros on each atom. You wouldn't have enough atoms to write down this number. That's the degree of precision of the thermodynamic state of the original universe in order for us to be here now. And so where did this precision of information content come from for the thermodynamic potential of the universe? Penrose writes, "These observations imply that the early universe was in a very low entropic state, which shows that its initial conditions were extremely fine-tuned. The reason for this fine-tuning are not explained by general relativity or the standard model. Adding inflation means you flip gravity on its head, and instead of attracting things, it pushes things away. That's inflation. So adding inflation models does not cure this fine-tuned problem. So how are you going to get around it? But isn't figuring out how to get something from nothing the very basis of science itself? According to Dawkins and Hawking and Krauss, you would think it is. And here's a little interview with Richard Dawkins, if we can have some sound, describing how, hey, getting something from nothing is the goal of mainstream science.
I'm not so at ease with that as you seem to be, because it does seem to me that if there is a supernatural, superhuman intelligence that worked it all out, in a way that undermines the entire scientific enterprise, because we are, maybe an evolutionary biologist feels this more strongly, the whole enterprise of evolutionary biology is to explain how you get prodigious complexity and design from virtually nothing. We hand over to physicists when we can go beyond the virtually nothing to the absolutely nothing.
That's Michael Green, by the way. He's a physicist, so that's why he's laughing at that. So here's a little bit more description from Dawkins about what he's trying to get at here.
If the deistic God thought all that through and set up the laws of physics, then he would have to be damn clever. He would have to be the physicist to end all physicists. I don't care if he then withdraws. He needs an explanation in his own right. And it seems to me that the noble scientific enterprise is to start from as near nothing as you can get.
Yeah. So he said, even if you did have a God and he withdrew, the origin of God would still require an explanation. But they don't seem so adamant about the origin of infinity when they're talking about multiple universes and the quantum fields. Those things are eternal, and they have no problem with explaining where they came from. They're just eternal, right? So when you're talking about quantum fields, hey, they're eternal, and no one needs to explain that. But when you're talking about God, suddenly he requires an explanation. Really? You're not being consistent in your argument. In fact, all the time they're inconsistent in their argument, and they're willing to admit design in the universe, or even the potential for design in the universe, as long as you don't call the designer God. As long as you don't call him God, you're good to go, right? And here's some illustrations of this. Here's a little interview. It should give you the background from Ben Stein.
At the details of biochemistry, molecular biology, you might find a signature of some sort of designer.
Wait a second. Richard Dawkins thought intelligent design might be a legitimate pursuit?
And that designer could well be a higher intelligence from elsewhere in the universe.
But you're crazy to say it's God.
Heavy. Yeah. Yes, you can say it's anything you want, men from outer space, Martians, anything you want, but not God. Cannot be God. Right. It's not allowed to be God.
Right.
So that's inconsistent, right? As long as the designer's name is not God, you could have designers around that created life on Earth and interesting things in the universe, but it can't be God, right? That's just inconsistent. So same thing, a very interesting interview with Lawrence Krauss, who's a famous physicist today, young guy, considered kind of avant-garde. So he's interviewed here. He says, Brierly is interviewing him. He says, do you see any evidence for purpose in the universe? Krauss answered, well, maybe I would believe if the stars lined up and spelled out a message from God. Like, hi, Krauss, this is God, just kind of saying hi today, how are you doing, sort of deal. Then he would believe, right? If the stars all lined up and spelled out him a message, he would believe in God. But Brierly says, hey, no, you wouldn't, because that would be evidence. That wouldn't be evidence for God's existence from your multiverse view. If there are an infinite number of universes existing for an infinite amount of time, then anything can happen no matter how unlikely it is. Therefore, no evidence could convince you that God exists, since the unobservable, untestable, eternal multiverse can make anything it wants, including stars lining up and saying, hi, Krauss, how are you doing? Right? This is God. It can, anything is likely from that perspective, including, two-headed cows are not surprising, or 10-headed cows, or angels dancing on the head of a pin, or Arnold Schwarzenegger winning the lottery 10 times in a row, right? Or even miracles of the Bible, like someone being raised from the dead. When somebody goes up and say, arise from the dead, and they pop back to life, that should not be surprising to you from a multi-universe perspective, where there's an infinite number of universes out there, because anything, however improbable, can happen and will happen somewhere in the multi-universe. And so how does Krauss respond to this? He says, that's a true statement. I'm surprised he's being so honest in this interview. He says, that's a true statement. You talk about this God of love and everything else, but somehow, if you don't believe in him, you don't get any of the benefits. So you have to believe. And then if you do anything wrong, you're going to be judged for it. I don't want to be judged by God, and that's the bottom line. Right? So is it really science here, or is it more philosophy and avoidance of judgment? Right? That he's really concerned about. Because even if the stars lined up and spelled out, hi, Krauss, this is God, I'm just sending you a little message, he would not believe. Why? Because of the evidence? No, because he doesn't want to be judged. Whereas everybody else would recognize that immediately as, oh yeah, that's something interesting, that the stars lined up and spelled out a message like that. So here's a little discussion on why not God, why not be judged, right? Why don't they want to be judged?
They are so close-minded,
Yes.
and it really, I got the feeling from the movie that it's really not about science.
No, it's about them.
It's anti-God. They cannot allow God to be a part of anything.
Right, because if there's a God, then they might be judged. If there's a God who holds you accountable for your actions, you're in a lot of trouble. Now, I'm going to be the first to agree, I'm in a lot of trouble too. But there's a lot, but they cannot admit that there's a possibility of sin or a possibility of morality, and they can't agree on this basic thing. If man is just a speck of dust struck by lightning and then turned into a human being, then he has no moral responsibility. If we're all children of God, we have some moral responsibility because we all have some little piece of God in us.
Yeah.
That scares them to death. Okay.
Yeah, so it really boils down to the one thing. It's not really about science. It's about your personal philosophy and your view of God. And here's kind of an interesting summary by physicist Gerald Schroeder. He says, if the laws of nature created the universe, these laws must have existed prior to time. That is, the laws of nature would be outside of time. What we have then is totally non-physical laws outside of time creating a universe. Now that description might sound somewhat familiar, very much like the biblical concept of God, not physical, outside of time, able to create a universe. So, the extremely fine-tuned fundamental constants of universe, this is different from the fine-tuned thermodynamic potential of universe, which is extremely fine-tuned. The extreme fine-tuned fundamental constants of universe, like gravity and the size of electron and the mass of a proton, all those things, they're fine-tuned to a total of 1 part in 10 to the 500. Well, that's trivial compared to 1 part in 10 to the 10 to the 123. But 1 part in 10 to the 500 is still extremely fine-tuned compared to the number of atoms in the universe. That's only 10 to the 80th, right? So how did even the fundamental constants get so fine-tuned? Here's a little video clip from Leonard Susskind, who's a physicist, well-known physicist, explaining the cosmological constant and how it got to be so fine-tuned.
The general view of this, for most physicists, is that these fine-tunings are largely accidental, that the constants of nature are determined by some mathematical principles which have nothing whatever to do with our existence. Impersonal, mathematical, and we were just incredibly lucky that mathematics happened to give rise to a universe with all this kind of fine-tuning.
For a while it was possible to believe that the laws of nature were not so precisely set as to require the hand of a creator. But then a completely new fundamental property of the universe was discovered. An anti-gravity force present in space itself. It is called the cosmological constant, and when cosmologists calculated its effect on the evolution of the universe, they realized it had to be very finely tuned indeed.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part in 10 to the 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion that the cosmological constant arrived at such a tiny value by chance seemed to be out of the question. But the alternative explanation was also impossible to contemplate.
Physicists did not want to accept the idea that the laws of nature might be controlled by the benevolence of nature. There should be no reason why the luck should just have it that we can exist. It's too much, it's a stretch. It's much too far to stretch.
It seemed that hidden in the laws of nature was a value so precise that it was impossible to deny that our universe was designed. But a designed universe requires the existence of a designer, a notion that even the anthropic scientists did not want to entertain.
Yeah, which includes Leonard Susskind. He's still an atheist. And because of this, he does not want to entertain, even though you just heard him saying that it had to be designed, he doesn't want to entertain the designer. And so he's still an atheist, and he's favoring this idea of multiple universes to explain the designed elements of our universe. Instead of using a personal God, he uses an impersonal multiverse that is infinite, that can explain anything that exists here, despite however statistically unlikely it may be. But there are other scientists who reject that idea. Sir Roger Penrose again. The extremely high level of fine-tuning astronomers and physicists discern powerfully suggests purpose behind our universe. In other words, it's far more rational, scientifically rational, to conclude that the empirical evidence in hand best supports the God hypothesis. it's not rational to argue for a multiverse, an infinite multiverse, because an infinite multiverse undermines the basic idea of science itself. Science is based on predictive value, and there is no predictive value given a multi-universe that can explain anything and everything whatsoever. Australian physicist Paul Davies. Paul Davies waffles back and forth between agnosticism and atheism, and he's currently in the atheistic camp, but you can see how tortured he is in his thinking. He says, such stunning accuracy in the precisely balanced universe needed to support complex life is surely one of the great mysteries of cosmology. The belief that there is something behind it all is one that I personally share with, I suspect, a majority of physicists, that there must be a God who is responsible for these laws and responsible for the universe. Then he went back into agnosticism or even atheism, and then in 2014 he wrote, as a matter of fact, I believe that if somebody did the proper mathematical analysis, they would find that the complexity of the explanation of the multiverse, an infinite number of universes we don't see, is the same as the explanation of traditional theology, an infinitely complex God outside of the universe that we don't see. They're really the same thing in different language. Except, of course, if you believe in God, God can actually make decisions. He's personal, he can be loving, and all those things. A multiverse can't do that. Frank Tipler. When I began my career, he's a professor of mathematical physics in New York. When I began my career as a cosmologist some 20 years ago, I was convinced atheist. I never in my wildest dreams imagined that one day I would be writing a book purporting to show that the central claims of Judeo-Christian theology are in fact true, that these claims are straightforward deductions of the laws of physics that as we now understand them. I have been forced into these conclusions by an inexorable logic of my own special brand of physics. So he didn't really want to go there, but he's forced to conclude that there is a Judeo-Christian God out there. I don't know why he specifically went Judeo-Christian, but certainly the physics of the universe strongly suggests that there is a God behind it all. Charles Howard Towns, winner of the Nobel Prize in Physics from Berkeley. This is a very special universe. It's remarkable that it came out just this way. If the laws of physics weren't just the way they are, we couldn't be here at all. Some scientists argue, well, there's an enormous number of universes out there, and each one of them is a little different. This one just happened to turn out right. He says, well, that's a postulate, and it's a pretty fantastic postulate. It assumes that there really are an enormous number of universes, and that the laws for each one of them could be a little different. The other possibility is that ours was planned, and that's why it came out so specially. So, that's the first half of the lecture, actually. And hopefully the next half is basically little gadgets and little machines and little things that I think are impossible for a naturalistic mindset to explain. So if you guys need to leave early to go to church or whatever, I don't mind. But these things, I don't think even Hawking, Krauss, or Dawkins would actually argue that they weren't designed. So I'm not going to go into detail on random mutations and natural selection and all that, but the top diagram is Mount Improbable envisioned by Richard Dawkins. And he envisions on the backside of the mountain a gradual slope that you can slowly climb up by random mutations and natural selection. The problem statistically is that the mountain doesn't look like that. The backside of the slope looks like this, where it starts out in small steps, but each higher step gets exponentially higher. It's not just linearly higher, it's exponentially higher. And so the evolutionary mechanism stalls out in an exponential manner as you move up the ladder of functional complexity. And I can show you the math in detail after this if you're interested, or on my website. But that's the problem. Dawkins has a false view of the ratchet. The ratchet problem is exponential in nature, and Dawkins doesn't understand that because he hasn't done the statistical analysis to figure it out. So, also numbers in general. Math is the language of the universe, and math is actually seems to be the language of how God designed the universe. And there's beauty in math as well. I know some of you are thinking I'm crazy, beauty in math. Are you kidding me? But there is. And it's kind of ironic that some people say, hey, how would you recognize alien intelligence if they want to communicate with us? And I say, well, if you embed a mathematical a sequence in the radio signal coming from outer space, well, clearly that would indicate intelligent design. And oftentimes, for some reason or another, the cited mathematical sequence is the Fibonacci series, cited by Seth Sostak. In this case, he's a senior astronomer at the SETI Institute. But there's mathematical and meaningful sequences all over biology and the natural world, including the DNA sequence. It's a digital code. But let's talk about the Fibonacci series for a minute. The Fibonacci series is a very simple sequence of math. You take the first two digits and you add them together and you get to the next digit. 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, etc. Right? You see how it works? And then you can divide out these numbers and you get this golden ratio, 1.618, blah, 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 blah. And you would say, well, how in the world is this found in nature? It's all over the place because you can create these shapes using this Fibonacci sequence. You've got the golden rectangle, you've got the golden spiral, and you got the golden ratio. And you can see this in human design stuff all the time. It's used in the Parthenon. The Greeks loved the Fibonacci sequence. But it's also used in nature, everywhere. Everything you look at, lots of stuff is based on the Fibonacci sequence. You can see it in eggs, you can see it in plants. This is a cross-section of a worm, and you can see the spiral there. Pine cones, flowers, seashells, even galaxies. Here's a computer-generated fractal that also shows the Fibonacci series in it. And you say, well, that's completely man-made, right? But here's a real-life thing. Anybody know what this is? No, it's not coral. Know what that is? It's Romanesco broccoli. And I think it's very attractive. Maybe not to eat, but physically attractive. Also, the human body. There's lots of things about the human body that are based on the Fibonacci sequence. All kinds of ratios. Your hand, the bones in your hand, the ratios are based on the Fibonacci sequence. Your ear, the profile of your face. Again, front face and side face, Fibonacci. The ratio of your hand to your arm, Fibonacci. So where did all that math come from? Because it doesn't necessarily have to be that way. There's no real practical necessity for it to all be balanced out that way. It's kind of, as you would say, beauty in nature, right? That doesn't have to be that way. So where did it come from? Also, there's other little things in nature that are very hard to explain, like a simple feather. You know where Velcro came from? The idea for Velcro came from feathers because you got a hook and a groove in feathers. And that's how the birds, when they preen themselves, they can line up all these feathers so that feathers can be both rigid and flexible at the same time and break apart without destroying the feather. And then you just zip them up like a Ziploc bag. They go back in. How do you develop hooks and grooves slowly where you get some flight benefit from it? From scales, supposedly. It's like, I don't see how you can go from scales to hook and groove Velcro gradually through random mutation natural selection. It just doesn't seem to add up. Bombardier beetle is also another interesting example of how you can get informational quality design, but it's hard to explain how you get it slowly. Here's a bombardier beetle shooting off his cannon. And here's a little documentary on it, if we can have some sound for this one.
It can create a chemical reaction within its body so violent that boiling caustic liquid explodes out of its abdomen. By pulsing the jet 500 times a second, it keeps its rear end just cool enough to prevent it being cooked.
But it cooked all those other little ants. You know, so here's a few of the details. It has like a jet engine. It has 28% hydrogen peroxide with hydroquinone, and it produces them here, and then it sends them to these little sacs where there is a holding sac, and then the sacs squirt them into these little combustion chambers, and where they pulse very rapidly so that the thing doesn't cook itself. You know, if any of these particular sections failed, you wouldn't succeed. You would either get a cooked beetle, or you wouldn't have any success in warding off your victims. So It's made of 2 cannons, internal separate chemical storage chambers. Combustion makes an explosion. Boiling hot liquid, 212 degrees. Smells awful. Makes a popping noise and turns to steam. And it makes a cloud cover for the beetle to escape. Plus, it can cook little things like ants. And so how do you do that slowly? It just seems very hard for me to imagine how that process would happen slowly. And I know people have tried, but none of the arguments to me seem to be rational. So here's some other stuff, basic, simple stuff that I think even evolutionary biologists or physicists would recognize as design. So I'll start with this as a little quiz. Could this be the product of mindless nature? Throwing up those beech wood on the beach just randomly like that? Yes? Sure. Could it be the product of intelligent design? Could someone have deliberately stacked that wood to look like that so it looks natural? Sure. Right. How about that? Just washed up on the beach like that. Right? Anybody believe that? What about Richard Dawkins? How about this? These stones, there was an earthquake and they just landed like that. Right? Anybody believe that? Even Richard Dawkins? I doubt it. How about that? This wall just threw up like that all by itself. How about even on an alien planet? Let's say the Mars rover is driving along and it finds a granite cube on Mars, about 3 feet by 3 feet by 3 feet, and it's perfectly symmetrical like this. Don't you think that'd hit the front page of every newspaper in the world? And do you think even Dawkins would say, yeah, probably some alien intelligence made that? Right? Of course he would. You're walking down the creek and you're just like, oh yeah, the latest flood just made the rock stand up like that. I just like the horses. Or Stonehenge. No one doubts that design, not even Richard Dawkins, amazingly enough. Yet the statistics for this are much more probable that it is a mindless mechanism that made that versus the universe. What about that? The seeds just fell like that and they just grew like that, all by themselves. Yeah, you know that some people, when these crop circles first started coming out in England and wherever, some physicists actually proposed an odd magnetic flux that naturally produced these things. It's like, come on. Even if you believe it's an alien intelligence that made it, that's more rational than believing some magnetic flux made it. Come on. These are upside-down trees stuffed into a beach in Norway. But, some hurricane just came along and shoved them in like that. Here is a tiny little, let's see, what's it called? Miniature, let's see, a plant hopper insect known as Isis, an Isis insect. It uses these gears to coordinate its jumping for its legs because it jumps so fast that it generates 400 Gs on itself, 20 times what a human body can withstand. And so the gears help it coordinate its legs because the nervous system doesn't react that fast for these little critters. Other hopping insects solve it a different way by using compression pads to make their legs go properly. But this one actually uses gears. These are the first gears identified in nature. They help coordinate movement to a precision of 1/300,000th of a second. And here's a higher power view of them. Now, what's the difference between those gears and these ones? Well, those other ones, they just evolved naturally, and these ones were designed, right? But they look exactly the same. This one is just kind of a cool little animal lives in the ocean. I thought it was kind of cool because of the geometry. And here's geometry that was produced by intelligent design. So how can you tell the difference? Here's a bacteriophage, and it looks like an alien spaceship landing on a cell. And it has all kinds of geometry to it. It looks like something mechanical that a human or some intelligence would design. So how do you explain that? Yet that supposedly just evolved. Here's a little video clip explaining it a little bit. So you got these different proteins, and DNA is pumped by an engine that has about 20 times the force of a car engine to pump it in there. And it uses ATP. And it loads the DNA molecule inside the bacteriophage head there. And it does it very rapidly. about 1,000 meters equivalent of fishing line put into a coffee cup under extreme pressure. And it's about 1,000 times longer than the diameter of the virus, the DNA molecule. The speed is about 380 base pairs per second. This is the external proteins going onto the bacterial head there to hold it in place. They all have to self-assemble. They have to have preformed just right in order to self-assemble like this. And dozens of different proteins are involved with this. Inside, you got the DNA all crumped in there under high pressure. Then you got the whisker and long tail fibers that get attached. The landing mechanism, basically. And they all have to be preformed just right in order for them to attach properly like that. And if you don't have all these systems preformed just right, your mechanism doesn't work at all. You don't get a functional bacteriophage. It's extremely complex. This is just a short portion of an hour video clip on the bacteriophage. So here's how it goes in actual liquid solution. This looks like an alien spaceship. Lands on the surfaces of the bacteria. And then that high-pressure DNA that's inside the head, it gets squirted out into the bacterium under high pressure. Then it breaks down the bacterial DNA, and its own DNA takes over the bacterium. Produces millions of itself, and then it destroys the bacterium to go on and destroy other bacterium. And you know that these bacteriophages are necessary for life. You know, one of the dirtiest rivers is the Ganges River, and yet it doesn't make anybody sick. Why not? Because these bacteriophages destroy the bacteria as fast as they're entering the water. These things destroy them. And so these bacteriophages are actually essential for life on this planet. They're obviously designed. So here's something that's actually a molecular machine generated by MIT students. A theoretical machine. And you're like, well, how do you tell the difference between this machine and a natural machine versus an intelligently designed one? Because here's another one, a different machine. It's also generated by humans. So then how do you just tell the difference between that and this, which is an ATP synthase machine that's present in every cell of your body, on the mitochondrial surfaces? In fact, this machine is actually more intricate in a lot of ways than those ones that we just saw that were designed by humans. And yet, if any little part of these machines are missing or aren't set up properly, they don't work. Here's a little machine that has little feet that transports vesicles in every cell of your body, and those things are filled with protein. So they transport them from one side of the cell to the other, wherever they need to go. And how do you set up a machine like that slowly? I mean, let's say you only have one foot. You evolve one foot but not the other one. Well, it's not going to walk anywhere. You know, you have to have it all set up very precisely. And how do you do that slowly? Here's just a slower animated version of that first video. Here's a video clip of another complex machine, DNA replicase machine.
Using computer animation based on molecular research, we are now able to see how DNA is actually copied in living cells.
It has little arms.
You are looking at an assembly line of amazing miniature biochemical machines that are pulling apart the DNA double helix and cranking out a copy of each strand. The DNA to be copied enters the production line from bottom left. The whirling blue molecular machine is called helicase. It spins the DNA as fast as a jet engine as it unwinds the double helix into two strands. One strand is copied continuously and can be seen spooling off to the right. Things are not so simple for the other strand because it must be copied backwards. It is drawn out repeatedly in loops and copied one section at a time. The end result is two new DNA molecules. What you are about to see is DNA's most extraordinary secret, how a simple code is turned into flesh and blood. It begins with a bundle of factors assembling at the start of a gene. A gene is simply a length of DNA instructions stretching away to the left. The assembled factors trigger the first phase of the process, reading off the information that will be needed to make the protein. Everything is ready to roll. 3, 2, 1, go. The blue molecule racing along the DNA is reading the gene. It's unzipping the double helix and copying one of the two strands. The yellow chain snaking out of the top is a copy of the genetic message, and it's made of a close chemical cousin of DNA called RNA. The building blocks to make the RNA enter through an intake hole.
This is real time.
They are matched to the DNA, letter by letter, to copy the A's, C's, T's, and G's of the gene. The only difference is that in the RNA copy, the letter T is replaced with a closely related building block known as U.
All right, let's see. There's one more, I think.
When the RNA copy is complete, it snakes out into the outer part of the cell. Then, in a dazzling display of choreography, all the components of a molecular machine lock together around the RNA to form a miniature factory called a ribosome. It translates the genetic information in the RNA into a string of amino acids that will become a protein. Special transfer molecules, the green triangles, bring each amino acid to the ribosome. The amino acids are the small red tips attached to the transfer molecules. There are different transfer molecules for each of the 20 amino acids. Each transfer molecule carries a 3-letter code that is matched with the RNA in the machine. Now we come to the heart of the process. Inside the ribosome, the RNA is pulled through like a tape. The code for each amino acid is read off, 3 letters at a time, and matched to 3 corresponding letters on the transfer molecules. When the right transfer molecule plugs in, the amino acid it carries is added to the growing protein chain. Again, you are watching this in real time.
This is a bacterial flagellum, how it's made. So it's made like an outboard motor. You set up the various aspects of it in order. And you got a central port that sets up the hook and arm, and it has a little folding apparatus called the cap. You have the hydrogen pump there to drive it. The cap has 5 little legs on it, and it folds these proteins as they come up through the hollow core, one by one. That's the U joint. And then a new cap comes up, and it folds the rest of the proteins for the rest of the flagellum, one by one. And it spins as it does this. Spins around. And this is slow motion. It does this very fast. you're like, there are a minimum of about 24 structural proteins that are required for this. They all have to be properly arranged with each other. And there's another 25 or so assistant proteins that are required for the proper folding and development of this apparatus in order for it to work properly. And if they aren't all there at the same time in proper arrangement, you don't get anything that works. You just have nothing. So how do you get something from nothing without the information already being there at the beginning? How do you get the proteins that decode the RNA that decodes the very same proteins that decode the RNA? It's like a chicken or the egg. How do you get that all at once? If you don't have everything there all at once, you don't have anything. You don't have anything functional at all. So is life really easier to explain than the universe? And the universe is, according to physicists, pretty much impossible to explain without a designer. And I'm telling you that the simplest living thing is informationally more complex than the entire universe. And even a single-cell bacterium is informationally more complex than all the fundamental constants fine-tuning of the entire universe. And so how is life that much easier to explain? Here's the Milky Way galaxy. You're in a tiny little planet in an average size, or a fairly large size galaxy actually. There's just found out that there's about 2 trillion, that's 10 times more than they thought there were, galaxies in the visible universe. So they're up to, and they're each fine-tuned in 1 part to 10 to the 500th to support complex life. But the simplest living thing, again, is more complex than that. So how do you tell which is designed and which isn't? What are the odds? Here's a little video clip to kind of illustrate the odds. The fine-tuned features of the universe, if you take them all into consideration, including including the thermodynamic potential of the universe, the fine-tuning required for that, it's actually more statistically likely that every tornado that ever occurred on this planet would have built houses instead of tearing them down. And so here's a little... So what do they say the odds are? Those are really actually quite good odds, right? Not bad, relatively speaking. So, I think I have molecular machines. I'll skip this one. Basically, we covered most of these already. This is another video clip. Metamorphosis of life. I'll go over this really quickly. A butterfly starts out as a caterpillar, and inside the caterpillar, there's these cells called imaginal cells, and it liquefies the caterpillar, and the caterpillar doesn't like the liquefaction process one little bit, so it mounts an immune response to attack the imaginal cells and try to wipe them out so it doesn't liquefy itself. But it loses the battle, and the imaginal cells win out, and they end up liquefying the caterpillar and turning it into sludge. Nothing remains of the original caterpillar at all. And then the imaginal cells, they use the sludge of the caterpillar to build all the parts of a butterfly from that. It's like 2 entirely different creatures in one. And so how does it do this? Well, first it builds a chrysalis. And how does it build a chrysalis? Well, it has knitting needles. It has these little crochet hooks. And it has to knit its own blanket. How did it learn to do that slowly? Let's say you have a hole in your blanket the first time around. Well, all the sludge leaks out, and you have no more butterfly. You know, if you don't do it perfectly the first time, you have nothing. You have to do it perfectly the first time. You have to knit how did it learn to knit its blanket? Slowly with all these crochet hooks, which are extremely complex. They look just like crochet hooks, knitting up its blanket like that. It's chrysalis. Here's another picture of them. The colors of the butterfly itself, it's not based on pigment. It's based on crystals, actually. And the crystals have no pigment in them, but the crystals have to be precisely formed. So you fly closer and closer into a butterfly's wing, and this is what it looks like. There's these tiny little ridges microscopically as you fly in really close. There's 1 micrometer in length. And so then you start to see color, diffraction of light. And what's it really based on? It's based on these tiny little things called gyroids, which are based on the same stuff your fingernails are made out of. But it's the shape of these gyroids, the three-dimensional shape, that looks rather beautiful, a pretty, rather delicate three-dimensional structure. And these things diffract light in different ways to make different colors that make the butterfly look iridescent. But it's all based on different shapes of different gyroids make different colors. You hit them at different angles, and they'll make even different shades of different colors. It's really kind of cool. That makes them look kind of metallic and shimmery, right? So all these things we've talked about don't really, as far as the greatest miracle of all, according to the Bible, the greatest miracle isn't the universe. It isn't living things. It's nothing that we discussed about so far. The greatest miracle, according to the Bible, is you and me getting a new heart. That's the greatest miracle of all, because what did it cost God to make the universe? He just spoke it, right? A few words and you're done, right? Poof. What did it cost God to make living things? Again, either come down and get your hands a little dirty, speak a few animals into existence, and you're done. But what did it cost God to make a new heart for you and me once we rebelled? It cost him everything, right? His own son, himself. He said, therefore, if anyone is in Christ, he's a new creation. The old is gone, the new has come, just like a butterfly. You're a brand new creature. And fortunately, God likes worms, because right now, I hate to break it to you, but you and I are all just little wormy creatures. Compared to God, you're just like a worm, but God likes worms. So let God be creative with you. And if you don't believe me, read Isaiah 41:14, where it says, don't be afraid, O worm Jacob, O little Israel, for I myself will help you, declares the Lord, your Redeemer, the Holy One of Israel. He called Jacob a worm. Come on. Wouldn't Jacob take offense to that? He might, unless God liked worms, right? Same with David in Psalms 51. If anybody was a worm, it was David, right? And so the worm, David, says, hey, God, create in me a clean heart and renew a right spirit within me. And David did not know what he was asking for right here. But God says, okay, I will remove your heart of stone and give you a heart of flesh. And Ellen White describes this. She says, the conversion of the human soul is of no little consequence. It's the greatest miracle of divine power, greater than anything else we've talked about. Because again, it cost God everything to provide this for us, to give us hope and a future, and yet he was willing to do this for us and give us this miracle. And that's the reason why we're here today. Otherwise, none of us would be here without the sacrifice of God. And because of this, you're very important. You're extremely valuable to God, because he created you and then he bought you. He said in Isaiah 49:16, see, I've graven you on the palms of my hands. Your walls are ever before me. So he's not going to forget about you at all, because you've cost so much for him to redeem. So he says, as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts higher than your thoughts. I know the plans I have for you, declares the Lord, plans to prosper you, not to harm you, plans to give you hope and a future. Yet here we are, stuck in our wormy selves in a very painful world. And we're going through a painful metamorphosis, if you will. And some of us are occasionally tempted to complain about our situation. And then when we complain, sometimes God gets a little sarcastic when we complain. In Job is complaining to God, and God responds to Job. And this is what God says to Job. He says, where were you when I laid the foundations of the earth? Tell me if you understand. Who marked off its dimensions? Surely you know. Who stretched a measuring line across it? On what were its footings set, or who laid the cornerstone? While the morning stars sang together and all the angels shouted for joy. Surely you know, for you were already born. You have lived so many years. Right? So God is basically saying, hey, Job, you don't know what you're talking about. All you need to do is trust me on this one. Maybe. And anyway, I'll just finish it up from here. So I invite you basically to trust God's creative power, even when the going seems to be very tough, even when you're asked to put your lives on the line. Because, who wants to stay a worm anyway, right? Do you really want to stay like you are forever? Or would you rather join up with God and and undergo a metamorphosing process and end up something much better than you could ever imagine you could ever be, and because of the power of God working in your behalf. And there's plenty of evidence that God is willing to do it. He's given his life for us, and he's given plenty of evidence in nature that he's there for us, that he's made everything for us, and that he has the power to do it. He has the power to turn you and me into something worthwhile, and turn something that really didn't exist before into something that does. So anyway, that's what my prayer is for myself and for you as we think about these things. Thanks again. Any questions? Now that it's already 11:40. No? Yeah, Ariel.
Just have to sit and marvel at this presentation. I mean, this is excellent. It's just, and the thing that really surprises me is that here we have a scientific community that insists on not including God in the picture, in spite of all the data that says the opposite. And the problem is deeper than data. We're dealing with attitudes. We're not dealing with data here.
Yeah.
And how can we help these folks?
Well, I think for me, since it seems like the big issue is judgment, everybody's concerned about judgment. I think the big issue then might be a misunderstanding of the character of God. Because for me anyway, I'm not scared of judgment because Jesus has already died for me and taken care of judgment, right? Judgment is now in my favor. I mean, the jury is rigged. You know, Jesus died for me. He's judge, jury, executioner, all the whole bit. He's taken care of it. He says, I've taken care of that guy, Sean. I know he's a little worm, but I've fixed it, right? And so I think if people understand God better, that he's not here to condemn. He's here to give judgment in our favor. Then maybe that will help some people. Yeah.
Well, thank you very much, Sean. I'm always fascinated with all these aspects of design, and it's just overwhelming. We can probably spend a whole eternity looking at aspects of design, divine design. One aspect that I don't hear a whole lot within the biological discussions, but I'm sure you probably agree with me. One evidence of design is in human history. I know you touch on it, the fact that we're here, and the miracle of birth, the miracle of new birth. I'm teaching a class now for the first time on the early history of Loma Linda. And when you go back and dig around the early history, the providential leading, the role of Ellen G. White, and so on, there's design. The odds were stacked against the existence of this institution where we're sitting right now. And so that's another aspect.
Yeah, once you start throwing prophecy in there, I mean, the Bible is the only book that has accurate prophecy, extremely accurate prophecies in it that are mind-bogglingly detailed.
I had
go
ahead.
Yeah, for me, that's just another evidence of specifically of design of the Bible. That it's not just designed by humans, but it's designed by divine power. Because only God is outside of time, and that means only God can see the future in detail like that.
I had a couple quick questions. One is, you had a lot of really interesting short video clips. Have you posted these on your website, or where do we, if we want to go back and review them, where do we see the video clips?
A lot of them are on the website, and some of them are just on my laptop.
Oh.
that I collect over time. So.
And do you care to comment on the response you get from hits on your website, as well as email you get, and what kind of response are you getting, especially from the secular audience?
There have been a few. Every year there's 2 or 3 people who write and tell me that they've either come back from atheism or convinced to reconsider God because of the website, and that's totally worth it. But there's, for every positive comment like that, there's probably 50 or 100 that are negative from it, because people are really passionate about the topic, and a lot of people, I think, aren't well informed. Like, they've been trained since early childhood along Darwinian evolutionary thinking, and they cannot imagine that all these brilliant minds have been wrong all along. It just boggles their mind. They cannot even think about that thing, and so it's hard for them to consider that some nobody from Loma Linda could possibly be right, and with all these famous biologists having made a big blunder like this. So.
Maybe I'm a little dense, but I don't understand why it would be so easy just to snap a universe into existence just because the sums of the charges are zero and the sums of the spins are zero, etc.
Yeah, I'm pretty dense on that too, because even though your charges and all the sums are zero for the energy of the universe, the information content to make it zero is extreme, because you have to divide it properly. You can't just throw it out there. You can just make a Big Bang. The Big Bang has to be extremely precise in order for everything to balance out properly. And that's what they're not talking about. The precision of it, the precision that's required for the universe to do what it does. Yeah.
Sean, thank you so much for the presentation. And what I'm going to say is a quibble of disagreement in one small point, and that has to do with the bacteriophages.
Okay.
There's no question that bacteriophages show evidence of design as so nicely illustrated. The question is, who designed the phages and the viruses? You remember that these are not living entities. Phages are simply complexes of nucleic acids and proteins, okay? And they bear every signature of being designed by the second greatest molecular biologist in the universe. His name is Lucifer. These viruses and bacteriophages are not required for, I'm sorry to contradict you, for existence of life on Earth, even if they serve some sort of a useful function in the Yellow River, okay? So I would contest very strongly that part. And they in fact show an evidence of a mind that is nipping at the heel of creation, trying to destroy it and undermine it. The Lord had foresight and provided countermeasures against viruses. We have certain protection against it on all levels. I would ask you to think about it and reconsider that tiny little phrase that you put in. But in terms of design, it's very powerful and it's beautifully illustrated.
Yeah, I used to think, well, I'd have to talk to you more on a side from this, but I used to believe that all viruses were evil, designed by Satan, like you think, as well. But I've started to change my mind. I think that perhaps there have been degenerative changes that have made viruses evil, certain viruses evil like HIV and whatnot, that were not, because there's a lot of degenerative changes in the natural world, like animals turning into carnivores, for example. They originally were told, and the Bible suggests it, and Ellen White strongly backs it up, that all animals were vegetarian, and that the adaptations for carnivore living have come around as a result of the fall. And to me, most of these adaptations are degenerative in nature. They can be explained by degenerative changes that are very easily explained by random mutation, natural selection. And they don't require a lot of design, extra design to cause these things. And so I'm starting to think the same is probably true about a number of viruses as well. That a lot of these changes that make viruses misbehave, let's say, are degenerative in nature and not necessarily require original design, or at least not all of it. And so as far as the bacteriophage in particular, I've read a lot about them, and it seems like a great deal of biologists recognize them as essential for life. And so I have to talk to you more about this later. I really respect you, Dr. Yavor, but I've done quite a bit of reading on this, and it seems like that human beings, at least human beings, and maybe complex life, like in mammals, for example, wouldn't be around without viruses. So I have to get in. I know this is like an hour-long discussion in and of itself. So anyway.
Well, I appreciate all of the sharing. All this information is really good stuff. A lot of the argument that you're reflecting here, though, in science is one that's going on in cosmology that's really between two groups. One in which is in favor of string theory and the wide variety of universes that could result from that concept. The other is about the theory of everything, TOE. That there's a nice, tight set of equations with a few parameters that can be used to explain the universe. So a lot of what you are presenting is not really an argument for or against God, but the type of direction science needs to go in terms of identifying where to apply their energies and understanding the nature of the formation of the universe. There's going to be a lot of work being done on in cosmology, looking at inflation and trying to test it, because that's going to give them indications of whether string theory or a theory of everything is going to be the direction. So there'll be a lot of stuff going on there. So that's where a lot of the argument is. And in terms of identifying nothing, it's between what you've described and what the science described. It's really just there's a lot of talking past each other, because the definition of nothing is different from what you're defining as nothing, as what we would think of nothing here, than what science is defining as nothing. Nothing just means things add up to zero from a scientific perspective. Potential energy can be identified as zero at any location in a complex system. You get potential wells, or you get potential energy that can be converted to work. Depending on where you define zero potential energy. So that's so what you're describing here is not so much an argument of that they're not understanding what we're talking about. They have their own definition for what nothing is, and that's what's driving them, is that definition, not what and they're not going to listen to us in terms of defining what nothing is. That's going to be their
Yeah, no, but we need to not stop talking. I mean, we need to stop talking past each other. What they defined as nothing really isn't nothing.
We do the same thing when we try to define what science is. It's just the same type of argument, and so we have to be willing to accept that their definition of nothing.
I accept their definition of nothing, but their definition of nothing isn't nothing. That's the problem.
Yeah, but that's
what I'm trying to explain
from
here.
a scientific perspective, it is a definition of nothing.
It is a definition of nothing, but their definition of nothing is nothing physical. That doesn't mean that they base it on absolutely nothing. There's still a quantum field that they can't explain.
But why do you have to define it as absolutely nothing? For example,
because I'm trying to explain the origin, the basis of the quantum fields themselves is not nothing. And that has not been explained by science, and it can't be explained by science.
No, because you got to go beyond inflation in order to get to that.
Right. The inflation itself is dependent on something.
We just haven't gotten there yet.
You can't get there. That's the thing.
Well, we couldn't get to the idea of that there's planets out there, millions, billions of planets out there like our Earth, before just a few years ago. And what's the difference of looking for another universe that might be like ours and looking for another Earth-like
because at this point, even theoretically, it's impossible to find another universe. I mean, where's the empirical evidence for it? I mean, even theoretically, how would you decide? How would you detect if there was?
Well,
let's say you did detect if there was.
When was mathematics created?
Huh?
When was mathematics created?
In ancient times.
No, it was never created. It's always been there. And
Well,
if
it
you look
depends
at
on how you define the creation of mathematics. There's discoveries in mathematics that have not always been there.
Yeah, absolutely discoveries. But just think of the number pi. Everybody's social security number here is in the number pi. And that existed prior to creation. Does that mean that there was information about us in the number pi? So
Now, but see, now you're starting to talk, again, like I said, everything ends up, before you started talking about the Big Bang, everything is based on ideas of mathematical symmetry and beauty and all these things you're talking about. That's fine, but that's not science.
It isn't? Where did Albert Einstein start out with relativity?
Math can be very theoretical, but it doesn't necessarily reflect the natural world.
Yeah, but it wasn't it science when Albert Einstein came up with the theory of relativity. He never
It's only
stepped
science. Science is defined, not in math, but in testability of the natural world. Can
That's
you test
right.
it
We will
relative to
get
the
to
natural
that point. Science can get to that point once they've explored.
world? Not if you have only a purely mathematical theory. That's not science.
That's your
No,
that's your
everybody's definition of science. A purely mathematical theory is not scientific by definition. Science must be testable in the empirical world.
But a scientist uses the mathematics to establish his baseline.
No, it doesn't.
That's what exactly Albert Einstein did. He never stepped into a
It turns
laboratory.
out that the universe is written in the language of math, but that doesn't have to be that way. The universe does not have to be mathematically rational. And Einstein described that himself. He said it's a miracle that the universe is mathematically rational. That's a miracle that's not understandable by science. And so to have a mathematical theory that's beautiful and everything is not necessarily scientific reflection of the real world. That's why you still have to go and test your theories based on the real world. You can't just have a mathematical theory floating out there somewhere. That's not science.
But we have this, the history. You're not listening about.
I know all about the history of math and how it relates to science, but that's a miracle in itself. The language of math and science and how it relates to the physical world does not have to be that way. Anyway, we can talk more afterward. Go ahead.
One thing I think ought to be said, and can only be said by such as I graduated from here over 60 years ago and studied all of this close to 70 years ago. And at that time we heard of bacteriophages, and of course we knew about viruses, and we knew what they did. But I remember being totally mystified. How can that be true? What on earth, how does it work? And now you've actually shown us, yes, computer generations, but they're the next thing to how they are actually functioning with little feet walking down the street. That is infinitely more informative, and it does something for the brain in terms of comprehension that you can't comprehend on how mysterious it was 70 years ago. And I just think that in terms of magnitude of comprehension that we have been given since 70 years ago when I first started in learning all of this, it's almost of the order, and perhaps it is a form of the latter rain. I really felt that ought to be added to what you're saying.
Thank you, Wes. One more?
There's another possible explanation of how some of these rogue viruses were formed, because they found a strange instrument that looks like a tweezer and in a piece of coal. And more recently, the scientists that are working on chromosome things with cells, the instrument that they use looks very similar to this ancient piece of instrument that was found in a piece of coal, which very likely was being used before the flood, which could indicate that they may have been doing some cell manipulations before the flood, and they may have created rogue viruses that time. And there's some research or some literature suggesting that there's a research lab in the United States that has created some rogue viruses and rogue bacteria as well.
God help us. Anyway, All right. Well, I don't want to keep you all too long, so thank you all for coming, and really had fun.